I want to talk about things that are needed in DevOps, and a couple of you I know have seen a little bit of this earlier. You can't have a DevOps environment if you don't understand how your environment works and you don't have a way to remove from the most basic options the human interaction. You have to have everything documented, which is probably the most painful part, and you have to have everything being able to set to where you don't have the bottleneck of a person. If you go from step 1 to step 2 to step 3, and Brian is responsible for everything that happens at step 2 and no one else but Brian knows how it works, you have a problem in your workflow and you can never truly get into a DevOps environment. That being said, configuration management really fits this up. In the olden days, so I've been in IT for over 2 decades, you had to go directly to the system to do any changes. You had to log directly into your storage systems or directly into your servers or telnet directly into your switches. And you needed really highly complex information in those environments to do a good job. There was no way to remove those bottlenecks without hiring additional people, which wasn't as realistic. So then from there, companies went to the ability to have user interfaces that simplified the process a little bit. You still, in general, needed to have an understanding of what was going on, but not quite as sophisticated as you needed before. Examples from NetApp would be System Manager and the Element software web UI. These were great in making certain things easier, but again, they only accessed that one connection point. You can't log into System Manager and create your volume and then attach it to a server. So you still have a break and a handoff in a location that's going to cause bottlenecks. So most sites look at 3 ways of handling this in order to make this process go quicker. The first is they use APIs directly to write their own scripts or own applications. This is probably the most commonly done method, and it's also the worst. The reason this is not the way you want to go is because this then relies on whoever wrote that application as the point of contact and issue. If something goes wrong, it's your fault. You don't get to call me and complain that the software you wrote doesn't work right. If you go on vacation and something goes wrong, you're going to get in trouble because you're not there. And even then, if that doesn't happen, if someone comes in later to update it, they won't necessarily understand what's going on, and this piece of utility that your company's been using for a long time now could become unusable. And the last thing to pay attention to is no vendor has any obligation to make sure that their API changes don't affect your custom-written applications. So there's also no guarantee that your application will work from one release to the next. So some sites decided, I'm going to try to focus in on my as-a-service level. And I'm only going to allow, I'm going to have all my automation at my platform as a service or my infrastructure as a service level, be that Kubernetes, OpenStack, or some kind of VMware vSphere environment. And now this did relieve some of those problems. Someone who needed an environment could go through a web GUI or a single all-in-one connection program, but it only works within those environments. So what happens when you need to expand that cluster node? What happens when anything outside that environment comes up? You need to add more space. You need to add more physical network switches. Well, now you're back to a single-person problem and that bottleneck that you're going to have to deal with. And it wouldn't scale out from that point. But configuration management doesn't limit you to one application type or one platform type. It will cover a good configuration management will cover your entire environment. You'd be able to use it to configure your switches, to configure your application, to configure your servers, your storage, and then even your as-a-service environments in order to make the process of someone needing access to resources practically instantaneous without having to have physical humans be the one to pass it off for the next step. To that end, we are focusing strongly on Ansible. Why do we focus on Ansible? Well, for multiple reasons, not least of which is there are over 2,000 modules available for Ansible. So you can configure your switches, your applications, your cloud platforms, and have one configuration management tool to control all of this. Additionally, it is client only. What that means is you only have to run it from the place you install it at. You don't have to have agents on all of your systems you want to manage. It makes it far easier to control, to update, and to quickly get running. It's modules only. There's no extra intermediary servers you need. We also support Puppet, but for Puppet you need an intermediary Puppet client that then talks to your ONTAP systems. Procedural versus declarative. For a storage point of view, this works great. You want to make sure that you're able to say, do step A, then step B, then step C, to make sure that there's no errors. There's no point in trying to map a LUN before that LUN exists. So procedural really works in a good format for that. It's idempotent. Idempotency allows you, once you've created these playbooks in your environment, to run them again as part of their own checks. We have a customer who has a requirement every 24 hours to audit their security settings. And so they have playbooks that they just have a cron job for, that every 24 hours runs and they turn in the output of all okay to their auditing group. They used to have to split it among 3 admins every morning to run that check, and now it's automated thanks to idempotency. We've responded to the incredibly high demand we get for Ansible from customers. 8 out of 10 customers easily are telling us they're using Ansible, they want Ansible, they're going with Ansible. And we've even had some customers tell us that if we didn't have Ansible, they would no longer have NetApp. It's become that important. Saves companies time. Everything you use should either save money or make money. This is a saving money point. I also want to point out, don't read all this is just a list of all our modules to show you how much work we're doing. I do want to point out, though, that NetApp is one of only 6 Red Hat certified Ansible supported module vendors. So we go through not just the standard community tests for our modules to become part of Ansible. We then have another sometimes month-long process with Red Hat directly where they pour through all of our code and verify that we don't have any issues or problems within that point. We also release directly with Ansible. And finally, what I'd like to show is I'm trying to explain to often sites where the advantages stick with Ansible. How can they put these to their customers? So I'll use an example of, I have an end user that's creating an application that requires NFS space. Their host does not have NFS mount, doesn't have an FS tab entry for this NFS space, but I want to make sure we have little to no bottlenecks involved anywhere in this process. So I could, within Ansible, I can create an Ansible playbook that does all the things I want to have checked. Make sure that their department vServer exists and is accessible. Make sure the data lift exists and is where they need it to be. Make sure that the volumes, NFS status, a whole bunch of stuff that I can do with Ansible. But I'm not going to hand this to my end user. I'm not going to expect them to have even the level of knowledge that Ansible has. You always consider the lowest common denominator for your end users. I call it the mother test. If my mom understands this, then it's good to have into a general public. So what I like to show is you can actually tie this into this is just showing that nothing exists here, but you can actually tie this into a self-service portal. This is one I wrote myself in Flask. It's incredibly simple. All I have to do is fill in the data. A real environment would probably have some drop-downs involved. But from here, my end user puts in their department name, their application name, the size they want, and the host they're going to need it attached to, and they run this. This takes about 10 seconds to run. As it's going, it creates the SVM, because in this case, that department SVM didn't exist. It creates the volume that they're needing and all the configurations for that point. And finally, it accesses it on the host, now has that NFS mount and that FS tab set for consistency through reboots. This was 10 seconds. End user with no understanding of what was going on was able to just fill in the request and have everything taken care of idempotently. If you'd like to learn more about this, I have 2 sessions. One that deals with ONTAP examples and one that deals with Element software examples. The Element software session is tomorrow at 11:30 and the ONTAP session is tomorrow at 12:30. Thank you very much for your time.